I have a big confession. This video is exposing me for the super nerd that I am, but I have to get this out of my system. Hi, I'm Anne, and this is my living electric language. Today is going to be a deep dive into what is known as RMSSD, or root mean square of successive differences, which is quite the mouthful. RMSSD is the measure I suggest you look at for heart rate variability. And that's because it really is used in a lot of research that looks at how our heart rate variability is connected to our emotions. Heart rate variability is the flexibility of our heart's electrical system. Now, the vagus nerves are one of the largest nerve networks in our body, and they are connected to our heart's electrical system. They are responsible for slowing down our heart rate or speeding it up. How fast the vagus nerve network is able to slow down our heart's electrical system or speed it up quickly as it's needed, it is known as vagal tone. And RMSSD is an index of this vagal tone. The higher the RMSSD value, the higher the vagal tone we have in our body. And that means the higher heart flexibility. And higher heart flexibility leads to better health and well-being outcomes, especially emotional well-being. Find out more details in this paper, which I will link in the description below. So the intent of my video today is to show how you would calculate RMSSD for, like I said, super nerds like me who just really need to know. So I will be going into excruciating details. And if math isn't your thing, then go ahead and watch this video here on how you can measure your heart rate variability. Get your snorkel mask and let's dive on in. Let's start with the basic unit measured for any heart rate variability index, the interbeat interval. Now, interbeat intervals are the time between adjacent heartbeats, as seen in this graphic. Here, we see that the measurements are very precise. They're taken in milliseconds. And in this example, which is a real example from one of my heart rate variability readings, we have interbeat interval values that are 1,185 milliseconds, 1,066 milliseconds, and 1,110 milliseconds. These are actual readings that you are going to see in the following graphics. Now we can take these IBIs, these interbeat intervals, and represent them on a graph where each of these bubbles, these pink dots, represent an interbeat interval. So this graph is going to help us understand RMSSD better. I'm going to go through its parts in detail. The following was covered in my video about heart flexibility is our emotional power. So if you watch that and don't want to go through this again, skip ahead to the RMSSD definition in the chapters of this video. The first component of this graph to focus on is what the horizontal line tells us. The x-axis here is the time during a reading in seconds. So when we take a heart rate variability reading, we do it in a certain amount of time. In this example, I did a 2.5 minute reading. So that's a scale of 0 to 150 seconds because this scale is in seconds. It's showing when an IBI occurred during a reading. The pink dots that we see towards the left of this graph are those interbeat intervals or IBIs that were read early in the reading. And those pink dots that are seen towards the right of the graph are the IBIs that occurred towards the end of the 2.5 minutes. Our next component is what is known as the y-axis. That's that vertical arrow that goes up and down. This tells us how long an interbeat interval or IBI lasted in milliseconds. For this particular graph, our minimum value is 400 milliseconds and our maximum value is 1400 milliseconds. So the pink dots that are lower on this scale are shorter interbeat intervals. Those pink dots that are higher on this scale are longer interbeat intervals. That is, they lasted longer in time in terms of milliseconds. The third component of this graph is the bubble size. So where does the bubble size come from? Well, this is where we get into RMSSD because the bubble size is directly related to how we calculate RMSSD. This brings us back to our interbeat intervals. RMSSD stands for the square root of the mean of the squared differences between adjacent or successive interbeat intervals. Adjacent or successive meaning exactly the same thing. The S stands for successive. Well, that was a mouthful. What does this really mean using the numbers and the graph in our example? This is a 6-step process. First step, find the differences between adjacent IVIs. In this example, we can look at the first two intervals. We subtract the first interval from the second interval. That means subtracting 1,185 from 1,066. This gives us negative 119 as a value. We do this for the next pair of adjacent interbeat intervals. So we subtract the 1,066 now from its successive interbeat interval of 1,110, and this gives us a value of 44. Step 2, we square this difference that's between these adjacent interbeat intervals, meaning that we multiply that negative 119 by itself, which gives us the value of 14,161. Between our next successive interbeat interval pair, we multiply their difference, 44, by itself, which gives us the value of 1,936. Now this is how we connect the graph with these values. So our bubble size are these squared differences. Here we see the bubble that is representing the 14,161 squared difference between our first two intervals. And this bubble here represents the squared difference between the next two intervals. Step 3, we need to take a break. So let's take a cleansing breath. So we're going to do an inhale for 4 seconds and an exhale for 6 seconds. Inhale. Exhale. Great, now let's get back into it. Okay, now on to step 4. When we add up all the bubble sizes in this graph, we get the very large value of 624,863. Our next step, step 5, is to divide this number by the number of bubbles. The number of bubbles we have is 136. This division gives us a value of 4,594. Step 6, we take the square root of 4,594, and that equals 68. So our RMSSD value for this particular heart rate variability reading is equal to 68, and the unit on that is milliseconds. 68 milliseconds can be thought of as being high heart flexibility. The higher the RMSSD number, then we have higher heart flexibility. And with this graph, what that is represented by are lots of big bubbles. Lots of big bubbles means we will have higher RMSSD numbers. We can compare that to this graph, which has lots of small bubbles. Now, lots of small bubbles will mean that we will have low heart flexibility. It also gives us lower RMSSD numbers. The RMSSD value for this graph is 15 milliseconds, which is a low heart rate variability measure. I took a reading of what my heart rate variability was while I was filming videos because I get pretty nervous. And so I would expect that my heart rate variability would not be very high because of my nervousness. In this bubble graph, what this is representing is an RMSSD equal to 31 milliseconds. And that's right in between high flexibility and low flexibility, meaning that while I'm filming, my heart isn't totally flexible. It still, though, retains a bit of flexibility. I can still feel a sense of calm so that I can get through this somewhat overwhelming process. RMSSD is essentially a measure of the average difference between adjacent interbeat intervals. Now, I use these same high flexibility and low flexibility graphs to talk about how high flexibility gives us emotional power in this video here, which is my first video. Well, if you stuck with me this long and you still have questions, put them in the comments below and I'll try and answer it. And again, if you want to learn more about heart rate variability or just see what I'm up to with measuring my heart rate variability, go ahead and subscribe to my channel. Also, if you liked this video, which if you're a nerd like me, why wouldn't you? Go ahead and hit the like button below. Next time, I'll be showing you a comparison between light versus electricity in terms of measurements. See you then.